Back, problem 8, fundamental theorem. Use the fundamental theorem of calculus to evaluate if it exists integral negative 5 to 5 7 by x cubed dx. If the integral does not exist, type D and E as your answer. Aha, this should be a giveaway because this is a rather tricky problem. One is very tempted to use the fundamental theorem of calculus. But watch the fundamental theorem of calculus. What does it say? Suppose f is continuous on your closed interval. That is an important condition, mind you. So what happens to 7 over x cubed? Well, 7 over x cubed has an infinite discontinuity. See, you need to be continuous to be able to use fundamental theorem of calculus. So we cannot use it. Now, if you cannot use it, can you find area under this curve in a certain fashion? Let us look at the curve. Negative 5 to 5, it goes to positive infinity here, negative infinity here. In some sense, they cancel each other, but infinity minus infinity we do not know to calculate. So we cannot cancel these two. In other words, this limit and this limit are not defined. Right? They are at present going to infinity here, negative infinity here. All we can say is limit does not exist, or that integral does not exist. Okay, it's very important to watch. Negative 5 to 5, the limits of your interval, are they allowed for the function in question? So always keep an eye out for tricky questions. What if the function is not defined in the interval? Then you really need to think it through using a graph or something like that. Okay. Now, next question, problem 9. Use the fundamental theorem of calculus to evaluate integral 0 to pi over 4 7 secant squared t. Secant squared, secant is 1 over cosine. Cosine is 0 at pi over 2 and negative pi over 2. All right, pi over 2 and 3 pi over 2, it is 0. Likewise on the negative side, negative pi over 2 and negative 3 pi over 2. Basically, 0 to pi over 4 secant is well defined. So there is no problem to this. So that is a good thing to always check. Secant is well defined between 0 to pi over 4 because secant is 1 over cosine, and 1 over cosine. Cosine by itself does not go to 0 from 0 to pi over 4. So 1 over cosine is well defined here. All right. So now let's play with that problem. We are going to use the second part of the fundamental theorem of calculus. In other words, you need an antiderivative of f. Antiderivative of secant squared is tan t. Remember, derivative of tan is secant squared. So antiderivative of secant squared is tan. So you have found an antiderivative. All you need is 1. No need to write constant. 0 to pi over 4 of 7 secant squared t dt is, evaluate antiderivative at the upper limit minus evaluate the antiderivative at the lower limit. Okay. Tan of pi over 4 is 1. Tan of 0 is 0. So 7 times 1 minus 7 times 0 is 7. All right. Until next problem.